Greetings to all. My name is Mukund Savadia. I am currently pursuing my MTech in CSC Data Science. My roll number is 23MCD016. My topic for the term paper of this complexity theory in algorithm course is understanding cadence algorithm for maximum subarray problems. We will go through the algorithm. I will be explaining the cadence algorithm with the time complexity and understand with one example. We will be discussing the algorithm's advantages and disadvantages also. Before jumping onto the algorithm, let's understand maximum subarray problem. The maximum subarray problem is the task of finding a contiguous subarray with the largest sum within a given one-dimensional array of numbers. Maximum subarray problems arise in many fields, such as genomic sequence analysis, computer vision. In genomic sequence analysis, it employs the maximum subarray algorithms to identify important biological segments of protein sequences, and these problems includes DNA binding domains. Whereas in this computer vision, the maximum subarray algorithms are used on bitmap images to detect the brightest area in an image. Although the maximum subarray problem can be solved using several different algorithm techniques, including the brute force, divide and conquer, dynamic programming, and reduction to shortest paths, a simple single pass algorithm known as cadence algorithm solves this efficiently. J. Kadane was the one who proposed this algorithm in 1984, and which is as fast as possible to solve this maximum subarray problem. I gave the overview on where the algorithm is useful in real life. So now let's look into the algorithm itself. In the initial step, n, n is set to the length of the input array, and this value represents the number of elements in the array. Second is the variable initialization. There are actually two variables, best sum and current sum. Best sum is initialized to negative infinity, and there is a reason for that, is that we want the maximum subarray sum. So the variable will keep track of the maximum sum subarray sum found so far. And there is the current sum, which is initialized to 0. So if the variable tracks the maximum subarray sum ending at the current element. Then there is the iterative process. The algorithm enters a loop, the for loop, and it iterates through the array from I equal to 0 to I equal to n minus 1. The starting index is 0, and this loop processes each element of the array one after one. And there is the main logic inside the for loop. And within the loop, the algorithm checks whether extending the current subarray by including the current element, which is array of I. Current sub plus array of I is greater than the starting a new subarray with array of I element, and this comparison determines whether it's more beneficial to start a new subarray or continue with the existing one. If it's more beneficial to start a new subarray, array of I is greater, current sum is updated to the value of array of I. Otherwise, if extending the current subarray is more beneficial, current sub is updated to current sum plus array of I. The algorithm then checks whether the updated current sum is greater than the best sum found so far. Best sum is updated to reflect the new maximum subarray sum. And at the loop conclusion, after processing all the elements in the loop, best sum contains the maximum sum of a contiguous sub array within the input array given. So this was the cadence algorithm where n is the length of the array, best sum and current sum, two variables, and then the for loop iterates over the every element. There is if condition where the element is uh, uh, gr- checked whether it is greater than the current sum plus array of I, and is updated to the current sum of the array of I itself, or else it is the current sum is updated with the current sum plus array of I, And if the if condition also checks that current sum is greater than the best sum. If yes, then the best sum is updated with the current sum value. And finally, after iterating over all the elements over the array, the best sum is returned. Implement the cadence algorithm. The flowchart can be found useful. And to write code in any language, here's the flowchart for the same. Uh, First, there is a start, then there is a end, which is the length of the array. Two variable initializations, best sum and current sum. Best sum initialized to negative infinity, current sum to 0. The iteration starts from of the for loop from 0 and goes up to n minus 1. So if the condition is true, then array of I greater than current sum plus array of I, then the current sum value is updated to array of I, and if false, then current sum value is updated to current sum plus array of I, and then the current sum is greater than or best current sum is greater than best sum is checked if condition. If it is true, then best sum is updated value is current sum, and false, then the I plus plus iteration goes up to the next iteration. And then if the I is less than n, if condition false, then the best sum is returned and the program is over. Now let's do the time and space complexity analysis for this algorithm. Cadence algorithm has a single loop that iterates over the array and which has the length of n. Therefore, the loop runs n times. And inside the loop, there are constant time operations performed, such as the if conditions, means comparisons, additions, and then the assignments operations. These operations, time complexity is the constant time inside the loop, so it is big O of 1. And since the input array is has a length of n, and the for loop runs n times, the array is only traversed once, and the overall time complexity of the loop is big O of n, and the algorithm contains no nested loops or recursive calls, so there are no additional factors to consider in the time complexity, instead the for loop. So therefore the time complexity of the cadence algorithm is big O of n. And as there is now talking about the space complexity, as there are two variables being used and no other additional space or arrays being produced, the space complexity is big O of 1. Okay, so let's debug this algorithm by an example. There are 20 elements, values in the array. From 1 to 20, there is 2, 3, 1 up to 7. So at the beginning of the algorithm, there is an initialization step. So there is no current element. The current sum is 0, and the best sum is initialized to negative infinity. So at the iteration of the first for loop, at the I equal to 1, uh, first element of the array, the value is 2. The current sum is set to 2 because array of I, which is 2, is not greater than current sum plus array of I. So the current sum is the value is set to current sum plus array of I, which is 0 plus 2, which is 2. And the best sum, as if condition in current sum greater than best sum, the best sum is minus infinity and the current sum is 2. So the best sum is initialized to 2. At the second iteration, the current element's value is 3 and the condition is checked if array of I greater than current sum plus array of I. So array of I is 3 and the current sum is 2. So current sum plus array of I is 5. So whichever is array of I is less than current sum plus array of I. So current sum is set to current sum plus array of I, which is 3 plus 2, that is 5. And the current sum is greater than best sum condition is checked. In that, the current sum is greater than the best sum, which is 5. So best sum is set to value 5. And in this way, up to last iteration, the current value, element's value is 7. The previous current sum was 63. So 63 plus the current element 7. So it is less. So the value is set to 70 of the current sum, and best sum is also set to 70. In another example, in the first iteration, the value of the current first element is minus 2. So the current sum will be minus 2, and then the best term is also minus 2. In the second iteration, the value is 3. So in the condition area of I greater than current sum plus area of I is 3, and the current sum is minus 2 plus area of I is 3. So it is minus 2 and plus 3, it is 1. And it is not, it is greater than, so area of I is greater than current sum plus area of I. So current sum is set to value of area of I, which is 3, which is 3. And then the best sum, current sum is greater than best sum. Best sum is minus 2 and the current sum is 3. So current sum is greater, so best sum is set to 3. Here's the working example of the for the cadence algorithm. Talking about advantages, this algorithm is very simple to implement and it is very less complex. The algorithm is highly efficient as we proved the time complexity earlier, and the time complexity is big of n, the n where n is the area size of the array. It can also be recommended due to its space complexity is big of 1, as there are no extra variables used, and the simplicity and efficiency matters. Now, talking about disadvantages, this algorithm is not appropriate for the non-contiguous subarrays, and the algorithm is designed in such a way that it can handle, or rather, we can say this algorithm works only for 1D array. So, now moving on to the conclusion, the cadence algorithm is useful for maximum subarray problems as this algorithm is very simple, less complex, and efficient. Hope you found this useful. Thank you for hearing me out.